Hi. So welcome to 12th standard physics. So we're going to have a brief introduction of what are we going to learn in this year, and we also will see how all these topics that we are going to actually learn in 12th standard are not just isolated from each other. They are all well connected topics. So we'll get an idea of how they are connected. And now you remember that in the 11th standard, we actually kind of studied about a lot of macro things, that things that you can see, things that you can feel, like mechanics, for example. It's a good example. We think about basically how things move, rotational motion, motion in translational motion, harmonic motion, lots of things that you can actually watch and talk about and mathematically model them. And then we went into trying to understand how the materials are actually behaving in a macroscopic level, like for example solids, liquids and gases, how they behave. And then we also learned a little bit about mechanical waves. So things that basically are all something that you can see at a macro level. Now we are going to go into things that you cannot directly experience or see. Directly see you can't, but you can experience though, and you can measure, and you can see a lot of things which are beyond our day-to-day understandability. So that's what we are going to study this year. So if you see, the topics that are going to be covered are all listed here from chapter 1 to chapter 15. So these chapters are covered in the NCERT book mainly. NCERT book covers these chapters, and there are two books. So one we call basically part 1 and part 2. So these are the two books that we are going to basically base it on, whatever we are going to do. So the part 1 is what we actually talk about in the first, let us say, 8 chapters. These first 8 chapters are all in the part 1, and the remaining chapters from 9 to 15 are there in part 2. This is part 1 and this is part 2. So if you look at part 1, the way it is constructed is, it is completely based out of concepts called as electricity and magnetism. Most of these topics are actually, all the topics are related to these two important phenomena in physics. Whereas the second one is a little more assorted topics, but they are also connected. And the last two topics, you can see semiconductor electronics and communication systems, are actually getting you into the applications of physics into engineering, like for example electronics engineering and communication engineering. So we're going to basically spend a little bit of time here to understand how these chapters are actually connected. So I'm going to start with in a slight amount of basics. Okay, so the things that you already know about, but you may not know how they are really connected. So let's say there is a charge. I'm going to write here. Basically, there is one charge. This is one charge. Let us say positive charge. I will call it as a charge. Okay, it may be positive charge or it may be negative charge. Let's call it as positive. Okay. The moment you have a charge, now the charge has what we call electric field around it. Okay, that is where if you bring another charge, it experiences a certain force. So we call that field is basically somewhat like this. So this is the field. So we call this electric field. So we're going to basically study about the charge and electric field in the first chapter. Okay, so we study in the sense that we are going to basically look at quantitative analysis of these things, and to get to understand basically how much charge will produce how much field, etc., and in what shape, in which direction, these kind of things. And then that electric field what we talk about, if it is not uniform, and let us say if that electric field actually is varying in space, okay, we call it as variation in space. Variation in space. I'm going to give you this underline here on the space, which means basically it is may not be varying in time. Okay, it may be varying in space. Actually, simply means at one point in space it has a certain value. At another point in space, by the neighboring point, it has a different value, and so on. So that is called value changing in space. So its variation in space gives rise to what we call electric potential difference. One point we call potential. If it is more than one point, between the 2 points, if we want to measure, it's basically called as potential difference. So, and that potential difference, actually what we call, is also responsible for a new property which we call capacitance of material. Okay, so till now we were actually talking in our earlier uh, in our earlier learning, we talked about resistance, where there is a flow of current. If it is there, something which resists, that is resistance. Now we are talking about one more passive circuit item, which is called as capacitance. Okay, which is dependent on electric potential difference. So we will talk about that when we come to the second chapter. Now, the moment you have electric potential difference and electric field is there. Now, suppose if the electric field, uh, now the electric charge, what we talk about here, if the charge is not, let us say, standing there, okay, and I'm actually having, let us say, a conductor like this. This is my conductor, and inside that conductor, the charges, let us say, are moving. I have moving charges, plus, plus. In fact, in reality, the conductor, very rarely you see a positive charge moving. In a solid conductor, what moves is actually a negative charge, which is what we call electron. So current is basically due to the movement of electrons in any kind of a solid conductor. So that means basically if electrons move from here to here, so we give a conventional concept of current to go from here to here. These are all strange things. Not worry about that now. Assume that positive charges are moving, and those positive charges movement constitute what we call electric current. Electric current. And we will study about this electric current in basically the third chapter. So we talk about current electricity. That is, whenever the charges move, we come across electricity, electric current. And we will actually deal with how to understand this electric current. What are the kind of circuits you can build using where the current can flow, and how to measure the potential difference when the current is moving. All that basically we will learn in uh, the third chapter. Now, the moment electric current is established in a conductor, it will so happen that around this conductor, you can see that there is actually a magnetic field that gets formed. So the magnetic field always actually will be there when there is a current that is flowing. So that basically is nothing but our topic for the next chapter, that is moving charges and magnetism. When the charges actually move, they create magnetic field. So that is basically we talk about moving charges and magnetism. Now the question that comes is that, is it that everywhere when you see a magnet, Are there moving charges there? Or is it only that whenever the current, see, look at this. We know that when there is current flowing or charges are moving, it produces magnetic field. Can we say from this that wherever there is magnetic field, it is because of the moving charges? That question we will answer. Or is it that it is possible to have a magnetism without moving charges? So these questions we are going to answer basically in magnetism and matter. And then we move on to see that this magnetic field, suppose if it changes, variation in time, see, I am now again putting it in terms of an underlining time here. See, here the electric field is changing, or there is a variation in space. That means at the same point in time, if I watch it at various points in space, the value of electric field is different. Whereas magnetic field here, if you see, I am talking about variation of that in time. When it varies in time, that means at the same point in space, if I actually talk about its variations, okay, in time, that means every few fraction of seconds, if I keep seeing it, its value is changing. So such a thing is called variation in time. When magnetic field is varying in time, it will actually produce electric field. And this is what actually we call as electromagnetic induction. And that electromagnetic induction, basically discovered by Michael Faraday, we are going to study in chapter number 6. So chapter number 6 basically covers electromagnetic induction, that is from electromagnetic field. When there is a variation in time, how electric field gets generated. I mean, that electric field basically also will generate electric current. If you pass it, if you keep a conductor, and it will pass electric current. So there is a whole circle here. You can see the electric current has produced magnetic field, and change in magnetic field has produced electric field, which in turn produces electric current. This kind of a loop is very interesting. Now, this is what makes electricity and magnetism work together. And a famous scientist named Maxwell actually got these two things together and created a mathematical model to deal with them as together and the same entity. So that is what we study when you go into electromagnetic waves, which is the 8th chapter. You can see how this loop of electricity producing magnetism and magnetism producing electricity, this loop is continuously possible to keep it up, in the sense that you are going to basically have magnetic field and electric field, both of them generating each other. Electric field and magnetic field are generating each other, and when that happens, actually we call it as electromagnetic wave. So electromagnetic wave is nothing but again interplay between magnetic field and electric field. So that actually kind of completes our part 1. Okay, so you can see very clearly that we are, the whole insight, if you look at what is there in part 1, is only this much, nothing more. This is exactly what you are going to learn by the end of it. And what is important is that while you are studying this, you are actually going through the details of each one of them. You are going to learn about the quantitative analysis of each one of them. So that is basically what is there in the first part of our physics. And let's move on to the second part. Now, once you talk about electromagnetic wave, you see the light actually is nothing but an example of an electromagnetic wave. Example is light, visible light. So when I say light, actually I talk about visible light. But light is really speaking is much more broader. You have ultraviolet light, infrared, gamma rays, radio waves, all of them are actually light. But let's use the word electromagnetic waves for all of them and use the word light for visible light. So however, most of these properties what we talk about for the light is actually for all the electromagnetic waves. So we are going to study many of these properties of light, what we call ray optics. And we will talk about basically some optical instruments which are basically used, which uses these properties. Now, the moment you talk about ray optics in the sense that you consider that the light is like a ray, means it goes in a straight line. It's almost like a bullet shot from a gun. So it goes in the straight line and rebounds exactly like that. So those are all some of the consideration of the ray optics. Whereas we see that there are lots of properties of light which cannot be explained using ray optics. You will have to actually rely on the concept of what a wave is and talk about a wave optics. So you can see whenever you say electromagnetic wave, you are already knowing that it is actually a wave. It's not a ray, it's not some particle. So the wave optics of light is actually discussed in the 10th chapter. What are the different aspects? Interference, for example, diffraction. These are the things that are properties of light and how it works. How do we model it using wave optics? These are the things that we are going to study in the 10th chapter. Now moving on to basically the 11th chapter is very interesting because this light, when you talk about, is a very strange thing. The strangeness of light is because sometimes it behaves like basically a simple particle which moves in a straight line, or sometimes it behaves like a wave, wavery. So it has some dual nature. So that dual nature we understand here in the chapter 11 and come to the modern understanding of light, which says that light actually is comprises of, contains basically, or comprises of what we call photons. These are like tiny, tiny energy packets which basically make what light is. So these photons, where do they come from? The photons actually come from basically an interaction within an atom. So we see that whenever, when you go back to your chemistry and start thinking about it, whenever an electron jumps from higher orbit to the lower orbit, the energy of the photon of the electron decreases because higher orbit has a higher energy, lower orbit has a lower energy. So you come from top to bottom, the remaining the energy that it releases goes in the form of a photon. So photon actually comes from jumping off electrons. So photons, where do they come from? They come from jumping of electrons between the orbits. What are these orbits? How are they characterized? What kind of orbits? So inside the atom, all that we are going to basically study in what we call atomic models, or under basically the chapter called as atoms. So we'll study the atoms from physics point of view. Okay, so you must have studied from the chemistry point, a little more deeper into it, more mathematical form. We'll get into the physics point of view and various models and how actually we can construct mathematical models for these atoms. So once you talk about atomic models and about electrons going around and all that, the next thing that comes is in an atom it is not just electrons. You have to get back into nucleus. So you will now then start talking about nucleus. So nucleus is a strange animal, in the sense that it actually holds together so many positively charged protons, and they are not repelling, they are staying there. So how is it possible? So what is the binding energy that makes it stand there? Who holds it together? What happens if you don't, if you allow them to split away, or if you break it? So there is something called as radioactivity. That means basically where some of these uh, particles naturally come out of the nucleus. And that radioactivity tells us a lot about nucleus. So we will study the nucleus and radioactivity in these chapters, 11th, in the 13th chapter. So that actually kind of completes our journey of the whole physics. If you think about it, most of the basic physics gets completed there. Okay, when you look at first year we dealt with basically all the macro properties of this world, and now in the second year we are talking about things that we cannot see. Electricity you cannot see. It happens because of the electrons, and we have seen how basically the whole things, all these things are connected. So next thing that we talk about, this is over. No, this is all about basically fundamental understanding of the pure science physics. Now we get into applications. So what do we do in applications? We talk about actually electronics. Electronics is one of the most important applications which happened in the last 30-40 years of physics actually. So if you look at electronics, it is fundamentally triggered by what we call semiconductors. These are some strange things. No? They are neither conductors nor insulators. They are in between, like germanium and silicon are basically what we call semiconductors. So the whole of this new age electronics that is built, including the computers, is basically through this electronics. All the computers what you talk about are all built using electronics. So that electronics is due to what we call semiconductors. We are going to study what are these semiconductors and what are the kind of materials that we are going to use. What devices you can make out of those materials like transistors, diodes, many of those things, and how those devices can be put together, integrated into small chips, and you will make basically the huge computers. So this will lead to you fundamentally electronics engineering and some basics and derived basics of computers. So that is what we are going to learn in the chapter which is 14th. So after completing this chapter, finally we are going to basically get into what we call communication systems. So we have seen that this light is a kind of electromagnetic wave. So we can actually go, it's an example of electromagnetic waves, not a kind, okay? It is an electromagnetic wave. So electromagnetic wave, if you see, if you get into slightly lower frequencies of electromagnetic wave, we call them as actually EM waves, basically. So slightly lower frequencies you call radio waves. So these radio waves are very useful. So the Bose in our country and Marconi in the Western world actually together actually invented this concept of using the radio waves for communication. So in a sense that we know that when a light goes from one place to place, it carries energy. Like we know very well that sun actually gives all its energy. Now we get most of our energy from sun through those those light rays. So it carries energy. But does it carry information? You can make the magnetic waves carry information. That is what we talk about here. Radio waves can carry information, and once it can carry information, we can use it for communication. You must have heard, all of you basically have basically heard FM radio, for example. FM is basically a kind of what we call frequency modulation. It's a method of basically taking your songs or whatever the music which is in the audible range and convert it or then basically modulate that onto the radio wave and send it. That's called one type of communication. There is AM communication, which is amplitude modulation. There is phase modulation. There are many different kinds of ways, digital modulation techniques. Many of these things basically we learn in our communication systems. So communication systems will give us an entry into communication engineering, which is actually the one which has kind of spread a lot in the recent years. So that will give us an entry into an application of physics. So these are the things that we are going to study this year when you are in class 12. So I think I gave you a sufficiently brief but at the same time connected information about all the topics that we are going to cover this year, and they are all spread out in these books very nicely. So you can actually read other books too, but this is basically what I use as what we call some kind of a skeletal structure to discuss about physics. Now, the next question that comes is, so I will actually allow you to basically take it this one and maybe take a snapshot of this, and I go out of the screen for you to basically do that. And then let's say we will ask a question on how I study this. How am I going to study this? How much time I will spend to study this? What is our course like? How much time we will take to do this course? So we will spend a little bit of time on that too. Okay. So fundamentally, I would like to give you a basic approach to the teaching that I am going to take you through. Is that the first part of our course, which is the first, what we I'll say, first few months, will be basically I'll be concentrating on getting the concepts right, going deeper into the concepts, okay, understanding the mathematical models, be able to do all the right kind of derivations and things like that, and at the same time do not lose track of the concepts and keep the interest going. So this is what I want to do for the first, let's say, 5 to 6 months and cover the whole syllabus. And then actually there will be time for getting into practicing for the exam, and there will be 12th exam, PUC exam is considered to be very important for your future, whatever you want to choose. So you need to basically spend a lot of time practicing. So while practicing, one can actually make a decision on or whether you want to target, let us say, IIT kind of a scenarios, or you want to target some other kind of a competitive examinations. All that you can decide, and depending on that you can spend more or less time on working on things. So and then it is possible to solve actually more harder problems and things like that. So I would like to make sure that you complete the whole syllabus and understand everything, and don't lose track of, don't get into basically examination mode from the day one. That's not going to help. You need to understand the subject. So understanding the subject requires you to have a freedom of thought and free mind. So I basically kind of advise you to go through the subject from the very interest it produces in you. Okay, so I'll basically make a small plan for how we go about, and let's see whether we can follow that plan. So now when we talk about doing it in 6 months, let's say we start in March 1st. Okay, so now if you go up to, let's say, August 31st, that would be giving you 6 months. Okay, and 6 months I would write it as approximately about 25 weeks. So we need to cover the whole syllabus in about 25 weeks. So how are we going to do that? So what is the amount of things that we need to do? If you look at all these 15 chapters, my estimate is that we're going to have about 75 sessions of approximately 1 hour each. That's what we are going to have. So that gives us an idea that about 3 hours per week is what you have to spend if you want to aim at finishing it in 6 months. Please understand that when I talk about 75 divided by 3 divided by 25, 3 hours per week. So this basically assumes that you work on all 25 weeks without break, and if there is a test or an exam or anything like that, then you are going to basically compensate for that. So that is basically the idea when I talk about 3 hours per week. And it is very important to make sure that whenever you are distracted by the tests and exams, you come back and compensate for it. Okay. So now 3 hours per week. Plus we have 1 hour of, let us say, a live session for discussions, etc. Whenever we have a 1 hour of live session per week. So totally you will get basically 4 hours on this. 4 hours just to know the subject, just to get a picture of basically the whole concepts and the derivations, everything. Okay. Plus, you are going to do some self-study. Self-study. That means what is that you are going to do in the self-study? You are going to basically go through the textbook, read any other material, and also you will look at the exercise questions and try to solve those questions. All that would be per week. I wouldn't be having more than, let us say, 2 hours for what we have done. So 2 hours if you sit together and solve some problems, maybe sometimes 3 hours would help better, but 2 hours is sufficient for most of the scenarios. So if we can really do it every week, that's good. So totally you got about 6 hours per week per subject. This is, I am talking about only physics. For you to plan ahead for the coming days, you, let us say, plan for 4 subjects generally: physics, chemistry, maths, biology, or physics, chemistry, maths, electronics, or computer science, any of these things, but basically 4 subjects. So I would say 4 subjects means we will have 24 hours per week. So the question is, how are you going to split this 24 hours in 7 days a week? So you probably have to do something like 3 hours per day for 5 days. Okay, let us say 5 days, 3 hours per day, which is equal to 15 hours. Okay, and Saturday probably you are able to get about 4 hours, which is 4, and Sunday you can get 5 hours. So totally we'll get 24 hours. So I'm not saying that this is the only way to structure it. I'm giving you an example of how to do it. Some children may want to basically leave their one of the days a little space for doing other things, and they want to load it on another day. Or some people want to spread it more evenly and take 4 days, 4 hours per day. So as you wish, basically depending on your other commitments, like you may have to write the practical records and so on and so forth from the school. So all that, when you consider, this is what is doable for our planning. Okay. So if you can plan like this, then we're going to be very comfortable. We're going to actually be completing everything by August 31st, know the whole subject. And if people want to take up competitive examinations, which are there probably even in November, some competitive exam starts in November, some of them in December, January, So we'll keep moving on. So you can start studying for them too. So this is basically my basic intro of what we are going to do in this course of physics, 12th standard for this year. So all the best for this year's physics course. Thank you.